Hello everyone, my name is Ian Smith and I'm the admissions tutor for the Civil and Structural Engineering programmes at Heriot-Watt University. I'm sorry that we can't meet in person on campus during the pandemic, but what I'm doing for you now is bringing an open day to you so you can watch online. Let me start off by telling you what civil engineering is all about, because some people might not fully understand yet what engineering, in particular in construction, entails. Well, we are responsible for the design and the construction of many aspects of the transport infrastructure that we see all around us, including highways. So we are responsible for designing some of the more integral junctions to allow traffic to enter and exit from fast-flowing highway motorways. We are also responsible for constructing and also maintaining that transport infrastructure. As it starts to age through time, we might have to resurface it, for example. So civil engineers are involved in all of the design, the construction and maintenance aspects. And it goes without saying, when you put a highway in somewhere, there will inevitably be a bridge. Bridges can either go over or go, or a highway bridge can go over a railway, or a railway bridge can go over a highway. And once again, it's the civil engineers who are responsible for the design and the construction of these fairly impressive pieces of transport infrastructure. Absolutely vital. There's sometimes small spans, sometimes very large spans. We're also responsible for designing and constructing impressive structures around the world. No prizes for guessing which football team I support. So whether it's a football stadium that we're responsible for providing, or for some impressive structures such as these structures here in the Pudong district of Shanghai. As civil engineers, we are capable of designing and then constructing quite impressive structures all around the planet. I mentioned the highway when we're talking about transport infrastructure. Obviously, there's a lot of air travel around the world as well. So it's civil engineers, again, who are responsible for the design and the construction of the airports, not just the taxiways and the runways, but also the terminals themselves to permit the flow of people and goods around those areas to safely get the passengers on and off the aircraft. So again, civil engineers are involved in that. Rail infrastructure. It probably doesn't surprise you that it's, again, it's the civil engineers who are responsible for rail, whether it's small scale local rail, it might even be urban light rail like tram networks, or it might be anything up to high speed rail. Once again, it's civil engineers who are responsible for the design and the construction, and also the maintenance of this important part of the transport infrastructure network. It's not just about transport infrastructure, we're also responsible for provision of water. Now, that doesn't just involve bringing water, so when you're in your kitchen and you turn on a tap, you get nice clean water coming out the tap. We're also responsible for providing the systems to remove the foul water away from homes and businesses and communities, to treat that wastewater before disposal. Around many nations, there are coastlines, not least the UK, and it's the civil engineers, again, who are responsible for providing the infrastructure, the ports and the harbours that interact with that, or at that coastline, that interact with the oceans. Increasingly, one of the growing areas of work of importance for civil engineers is, of course, the concern around climate change and possible rising sea levels and more frequent flood events. So flood management, flood control around the coastlines, and also in urban environments where there are rivers inland. It's the civil engineers who are responsible for designing the flood prevention schemes and then implementing them and maintaining them. So civil engineers are getting involved in so many things. Tunnelling, well, it's probably a fairly obvious application of civil engineers. We can tunnel through soil, or we can tunnel through rock if we go to a deeper depth. Often they are for the provision of transport infrastructure, so we can put trains and cars through these tunnels to allow us to bypass or to avoid any surface interruption. But also we use tunnels for the provision of water, hydroelectric schemes, and the removal of wastewater as well. Okay, so it's not just about the provision for trains and cars to whiz through tunnels. Energy is such an important aspect of our everyday life. Increasingly, the work of the civil engineer, we're involved in the renewable systems, whether they be onshore or increasingly offshore, like the offshore wind farms. It's the civil engineers who are responsible for the design and the construction, the installation. We work very closely, of course, with our friends in mechanical and electrical and power engineering, but it's civil engineers who are responsible for actually constructing the foundations and installing these important aspects of our energy infrastructure. Also, civil engineers are involved in the gradual decommissioning of the fossil fuels. So the oil rigs that are in the North Sea, it's the civil engineers who are getting involved. Still oil and gas that can be safely extracted, but slowly we're starting to see reduced reliance on fossil fuels, which is a good thing for the planet, of course, and it's civil engineers who are involved in that decommissioning work. When we put any sort of infrastructure in as humans, we don't just put it in and walk away and think all our responsibilities done. We are responsible for the whole life of that, including the demolition, if you like, at the end, and the decommissioning in the case of the oil rigs. So, in other words, if I was to sum it up, I could say that civil engineering, it's all about ensuring the future of our planet for all of society. And the way that we guarantee the future of our planet is that everything that we do, we must be mindful of carbon footprint, our carbon footprint through any of our activities and our impact on the climate. So we enter everything that we do, the design and the construction, with a sustainable hat on, so that everything we do is sustainable and of minimal impact to the planet, so that what our work does, it benefits everybody that's sitting on our planet. In terms of our programs, we offer both an MEng and a BEng degree, civil engineering or in structural engineering. As you can see on the screen there, the BEng degree is a 4-year long program and the MEng degree is a 5-year long program. And I'll mention entry qualifications in a few minutes. In terms of our teaching, we emphasize the importance of design work right from the start, right from year one. We're getting our students, excuse me, involved in design, whether that be structural design, highway design, geotechnical design, or water infrastructure design, so that you have a real understanding of the aspects and the various concepts that are involved in different types of design. A lot of our work as civil engineers is very practical based. So we will spend some time in the classroom and in lecture theatres, but actually you'll spend a good bit of time in the laboratories, bringing that theory from the classroom into real life practice and seeing what it means, and particularly around the world of materials. In civil engineering, we use a range of materials, and it's important for you as a civil engineer to understand the properties, the strength, the durability of these various materials. So you will go into a laboratory quite a lot of the time, different laboratories through in your early years. If you do a dissertation that is experimental based in your 4th year, I'll talk about the dissertation in a second, you might spend more time in the laboratory doing specific experiments related to your own individual piece of work in the dissertation. And as you would expect, I mean, a lot of our work, design work, analysis is done using software, absolutely industry standard software. So you'll spend quite a bit of time in computer labs as well, not just using this the office applications or email, but actually really learning and being trained in structural design packages, geotechnical design packages, various advanced mathematical analysis packages as well. What we also do is we take you out onto construction sites quite often, so you can really see civil engineering up close, and we will bring our friends and contacts from industry into the university to give various guest lectures to you. So they bring their projects into the university for you to learn all about. Normally, an open day would be held on campus, and after I'd finished giving a presentation in a classroom, we would take a walk around some of our facilities. We can't do that today, so let me just touch on we do have quite some world-leading facilities. We're very lucky on our Riccarton campus. We have a lot of space, a lot of large-scale laboratories in which we can carry out some world-leading research. into various aspects, whether it be high-speed rail, ground engineering, structural engineering, water engineering. And you as an undergraduate student can benefit from these incredible facilities that we have, because a lot of the dissertation work and some of the early laboratory work will cascade from this research work. So you as a student will get access to these quite impressive facilities. A lot of the laboratory work, well, in fact, probably all of the laboratory work in your early years is utterly designed to help you understand the theory that we're covering in the class and the fundamentals of engineering. So it really brings it to life. And there's a sort of light bulb moment happens in the laboratory. And you say, okay, right, I understand now what's happening. So you'll go into laboratories quite a bit. You're never allowed into laboratory on your own. You'll always be, it's for health and safety reasons, you'll always be there with one of the technicians. Each of our laboratory is manned by a number of technicians, or accompanied by a member of academic staff, such as myself, or as accompanied by one of the research students, one of the PhD students. Okay. Sometimes you're in the lab as the entire class. Sometimes it's a small group. Sometimes it's an individual if you're doing an individual project, but never alone, always accompanied by somebody else. Let me just explain a little bit about the structure of our degree. It might be of interest to some of you. So each of our academic years is split into 2 semesters. So what we've got along the top part here, we've got 4 boxes. That's representing semester 1. And these are the 4 subjects that you would study in semester 1. Semester 1 is September to December. Once semester 1 is finished, you would move into semester 2. That's from January through till about April time, and you would do another 4 subjects. So at Heriot-Watt, we do 4 subjects in each semester. And in order to progress to the next year of the course, you have to pass all of those. And once you pass year 1, you move into year 2, and you'll start to recognize you probably start to be confused by some of these words. You won't have recognized, you might not recognize these words. You'll spot these are new words, new terms. And this is all to do with the introduction of the more specialist geotechnical subjects, okay? In each of these, there will be theory, there'll be classroom, there'll be lecture theatre, delivery of the material, and there will be practical elements as well. So whether that be computer lab using software or going into one of those physical laboratories. Once you pass year 2, you move into year 3. And again, we start to introduce some more specialised topics that are key to all civil and structural engineers. And by the time we get to year 4, you start to see a lot of options appearing. And this is to help the students to choose either their degree in civil engineering or their degree in structural engineering. So the first 3 years are common, and at the end of that, you can start to choose subjects to make you more, if you have more of an interest in structural engineering, you might want to choose more structural engineering options. Otherwise, you go down a mainstream civil engineering route. There's involvement of industry in 4th year, and then you can see that there's a dissertation, and the dissertation project runs right through both semesters in year 4. So this is an individual project you work on under the supervision of an academic member of staff, such as myself, and that is an important piece of work. And that can be on any topic. So you start to choose subjects in 4th year that's relevant to your career aspiration, because by that time, you know, if you want to be a highway engineer, you want to be a geotechnical engineer like me, or you want to be a structural engineer, and you choose the subjects and you choose the dissertation subject based on your own interest. At the end of 4th year, students would qualify with a B-Eng qualification. If you reach a satisfactory grade, you can progress into the 5th year, the M-Eng civil engineering or M-Eng structural engineering year, and you can now see that it's a large amount of choice. So this is all about, there's a whole range of option modules for you to choose from. You can choose whichever one or ones are more relevant to your career aspirations. So that's what year 5 is about. Okay, there is a professional project that, once again, involving colleagues from industry to help you through that project. So that's a sort of fairly rapid look at the structure of the course. Our main goal, I suppose, is really about not just educating you as students to make it successfully as a civil or structural engineer, but we also train you as well. So what we do is we teach and we train so that you are what we would refer to as industry ready almost on day one. The day you leave university, you're ready for industry. So what we do, I've mentioned some of this already. We've got that strong emphasis on design that's throughout the course. You will have lectures and labs and workshops. You'll get the people from industry coming in. We'll take you out on the site visits. I've kind of mentioned a lot of this already. There'll be group projects that you'll be involved in. There's a lot of tutorial support, so you're never really on your own going through this academic journey. There's a lot of academic support to help you on that. In terms of assessment, it's a whole mixture of things, just like any other university. There will be exams, I'm sorry. There's coursework throughout the semester. There are reports to be submitted, and then there's the dissertation in that 4th year, as we saw earlier. And all of that comes together, really, to build your educational base up so that you're really ready for what industry wants. And we work a lot with industry. As new technologies and new innovations come into the industry, we make sure our graduates are fully equipped for the needs of industry. So we're in constant dialogue with industry. So we make sure the content is relevant all the way through. I've seen already on that little chart of the course of this program structure. Each semester you've got 4, we call it a course. So the individual block is known as a course. Some universities refer to that as a module. So 4 15 credit courses run per semester. That typically involves, for each course, about 4 to 6 hours per week contact time. So you're in the university around a course between about 4 and 6 hours per week. So you can do the arithmetic. You're around about the contact time, certainly in the early years, about 20, 24 hours per week. You will most likely find yourself staying on campus for a lot of the intervening hours between classes, when a lot of the students will use the library or the learning commons or a resource centre to keep studying away. And what we try to recommend is that you will do about self-study of about the same number of hours per week, around about 20 hours per week. Okay, and that's how where you really learn how to do the subject when you're studying and learning for yourself. And if ever you're stuck, you turn to an academic member of staff for help. Yeah, so there's a lot of support around all of that. I mentioned about site visits. So we take our students out on various site visits. For example, those of you that are from Edinburgh will recognise the 3 bridges over the River Forth. We'll take the students out there to see the maintenance aspects of these structures. We also take students out onto construction sites themselves to look at maybe a new railway going in or structures going in. Increasingly, civil engineering is moving into a world of automation and what we call off-site construction. So we'll take the students to the off-site manufacturing centre so that they can get a real feel for how things are assembled in a factory before they're shipped to site for assembly. The construction area is an opportunity for all students in 2nd year to spend a week on a construction site, specifically learning construction tasks. There's not many universities use this facility. So you're quite lucky in some respects to get this opportunity. It's a week on site. You learn all the sort of duties, all the tasks, all the responsibilities, and a lot of practical skills. And a lot of the students absolutely love this week. They learn so much practical skills from this. So it's a training site. It's not a live construction site. It's a training site. So trained civil engineers are training the students in all of the aspects. It might be working at height. It might be mixing concrete. It might be a site assembly, health and safety, whatever. We also go overseas. In 5th year, the students will spend a week in Barcelona. It's important to realise civil engineering, of course, is not just a UK-based pastime. It happens all over the world. So the MN students in 5th year spend a week in Barcelona having a look at the construction across there. We work with so many companies. So many companies recruit our graduates. Our graduates, as I mentioned before, they are industry ready on day one. So a lot of companies work in partnership with us. They recruit our graduates. They also offer summer placements as well. And a lot of these companies, we have friends in these companies who will come in, give presentations to the students about projects, or welcome us out onto various sites as well. And all of these companies will advise us constantly on what the emerging needs of industry are, so that our degrees are kept up to date and relevant, so that you as a graduate are highly employable at the end. Excuse me. Just almost to finish off now, professional body accreditation, you might not really understand what this is about, but these four logos on the screen here, these are four professional institutions of civil engineers, structural engineers, highway technologists, and highway engineers. They have we have full professional body accreditation on all our programs for what's called CEng status. And what that means is that these four bodies have come in, have inspected our courses, inspected our facilities, checked everything that we're doing. It's a sort of 5-year cycle. They've come in and they're absolutely satisfied that everything we're doing at Heriot-Watt is adequate for to ensure our graduates are ready to, on leaving university, to train up to become a chartered engineer. So it might not mean too much to you, that expression, accreditation, but it's actually a very important thing. So all of our degrees are fully accredited. The entry qualifications, what the important thing is here, as I mentioned earlier, years 1, 2, and 3 are common. So the entry qualifications for BEng, MEng are pretty well the same. You come into year 1, you progress to the MEng depending on your marks in years 3 and particularly year 4. Okay, so it's important that the MEng progression is based on performance, not really on the entry grades straight from school. But typically we're looking for these sort of range of higher or A levels, particularly maths. Okay, you must have maths. Normally we're looking for that at least at B, and other relevant subjects. So any of the sciences, English language, all of these subjects are very important to doing civil engineering. If you are a college student, you might qualify for advanced entry. We will take, or if you have good A levels, we would consider year 2 entry for a student with an HNC, and year 3 entry for students leaving college with an HND. Typically, we're getting about class sizes of about 80 students into first year, and about a quarter, sometimes it's about a fifth of those are female students, which is nice to see an increasing number of female students joining this important STEM subject. We do have the opportunity for study abroad. We are a global university, as you may know by now. We have campuses in Malaysia and in Dubai. Those campuses are also offering the degrees in civil engineering. So if you wish, at any point, you can study 1 or 2 semesters either in Malaysia or in Dubai, or 1 semester in each, because it's the same degree being taught at the same time at all 3 campuses. So you can certainly spend a semester studying abroad, or you can even study at one of our other international partners, either in the United States or in Europe, under an agreement. So you can spend at least a semester, if you wish, studying abroad, and it all counts towards your degree. It's not a bad idea. Okay, so just to finish off, why might you choose Heriot-Watt? Well, as I keep banging on about, we are very employment focused. What we are in the business of is producing confident and employable graduates. And in order to do that, everything we do must help you towards your degree, to help your employability. We do have excellent facilities. Do have a look on the website at some of the virtual tours to have a look at some of our facilities, because you can't get onto campus just now. There's a whole range of option subjects, as we saw in later years. A lot of staff contact, staff are readily available, and the opportunity to go global, that's the study abroad option. And we do try to offer as good a student experience as we possibly can, and everything we do is very much student focused, so that you don't only have a good and satisfying and prepares you for industry time at university, but you also have a very rewarding time at university as well, and you'll have good fun, I'm absolutely sure. Okay, and that takes us to the end of the presentations. Hopefully you found that useful. For more information, please visit the Heriot-Watt website, and one day I hope to welcome you to Heriot-Watt University. Thank you.